I'm going to talk a little bit about parent transformations, and I'll show you in Deltamath too, but just to get the idea. So I've started here with the f of x squared. Now remember, you've got many parent functions, but this is the one I choose to look at. So notice that the vertex is at 0, 0. So when you're trying to figure out what kind of transformation takes place, you're kind of focusing on where that vertex is and how it changed. So looking on this next image, if I do a parent function shift and I add a negative sign, so all I did was add a negative in front of my x squared. Notice what happens. My vertex does not move, but now I've got an upside down, or it flips or reflects over the x-axis. So note that the negative in front of the x squared, my parent function, always go back to your parent function, that negative causes the function to flip. So I'm going to get rid of that one. I'm going to talk about a different type of function. What about when I have a function that has a number in front of the x squared? So if I show you that graph compared to my parent function, you're comparing, I'm saying this over and over again because I want you to understand, you're comparing this new function, the 3x squared, to the original function, parent function, x squared. So looking at my graph here, you can see that the green graph is the one with the 3x squared. And how does that change from my original or my parent function, which is in red? Notice it becomes skinnier, or it is stretching away from the x-axis. So it's stretching or stretching closer to the y-axis. So how does that change? It gets closer. It's inside. It's skinnier than my parent function. What happens if the value of in front of the x squared is less than a whole number? So it's between the numbers of 0 and 1. So in this case, I have 1/8 x squared. Let's compare that to my parent function. Okay, you can see I've got the red parent function. The fraction is wider, or what we call compressed. So it is compressed. So it is wider than the parent function. So you're trying to identify how these parent functions shift, transform, change. And those are the words you're going to be using: stretched, compressed, reflected. So let's look at another kind of transformation. And this is the chart that you should have copied from the last page. I'm doing all these transformations. This is a big point. So if you're paying attention and you can understand this concept, you're going to get this really easy. Notice now I'm going to show you what happens when I'm still talking about a parent function of x squared because I got the squared, but notice I have inside parentheses together. So I have an x and I'm taking away 3. You need to think about this is going to be a horizontal shift. It's going to move left and right, and you have to think opposite day. If it's going minus and it's inside the parentheses or a square root symbol, or it's inside a absolute value symbol, it is always going to shift horizontally and it's going to go in the opposite direction. So you would think normally this would go -3. When it's inside parentheses, you do the opposite. So it's really adding 3. So look at, for example, let me show you the graph. Okay, parent function is in red. The shift is in purple or black, whatever that line is, color is. So from the vertex at 0, how does it shift if it's inside parentheses? And it's a minus. In this case, it goes 1, 2, 3 places to the right. So transformations is 3 places to the right. If you have a graph that has minus inside the parentheses, absolute value, square root, etc. So what do you think obviously is going to happen if it's now a +3 instead of a -3? Let's look at our graph. Hopefully you said, okay, this is going to shift. This is my parent function at 0. It's going to shift to the opposite of plus, so it's going to go negative 3 places. So it's going to move 3 places to the left. And you can change these. You can play around. I can change with numbers. And you can see that that changing that number of units. And I'll just stick with 3 for right now. All right, so let's look at another type of transformations. There's a lot of parent function transformations. You should have been exposed to these in Math 2. We're going to take it a little bit deeper in Math 3. I'm reminding you about these because when we get into trigonometric functions, we're going to talk about it again. So I now have x squared. The parent function is x squared. But notice there's no parentheses, and it's just a plus 2. Parent function, vertex is at 0, 0. The new one, the plus 2, it goes up vertically. So it rises 2 places up, goes up vertically. So guess what's going to happen if it goes down? Okay, hopefully you said, okay, my parent function is at 0, 0. And what happens? It moves down 2 units. So if it's no parentheses and it's going to be plus or a minus. Plus goes up, minus goes down. And inside parentheses, minus goes to the right, plus goes to the left. If you can remember that, it's going to just help you immensely. So what you're going to be doing, and I'll show you in Deltamath now, is you're going to have multiple transformations in one. So the x squared tells me it is a quadratic parent function. So parent function x squared. That's my graph in red that I've been always comparing it to. So all I did is looking at this, I typed in a series of transformations. If you remember what each one of these do that I explained, you don't even have to look at a graph. But we'll talk about the graph in a minute. But if I'm looking at the 1/2, okay, it's a positive, so it's not going to reflect, but the 1/2 is going to cause it to compress. I've got inside parentheses, and it's a -2. Remember, opposite day inside parentheses, so it's going to go to the right 2 places. And I also have a +4. The +4 causes it to go up 4 places. So just by looking at that equation, which is in vertex form, I can tell you how it transforms. But if you can't remember that, you can always type it into Desmos, and you can see parent function is at 0, 0. How do I get to that new vertex? Well, let's go up first. So we're going to go up 1, 2, 3, 4 places. There's our +4. Then from those 4, we're going to go over 1, 2. And if I go horizontally, they're inside parentheses, I have to think opposite day. So there's my -2 inside parentheses. And if you look at this graph, you can tell that it's a little bit fatter, if you will, or wider than the original parent function. So that 1/2 would cause it to be compressed or wider. So that's how transformations work. I know this video is long, but I want to get you to understand what you're doing. So in Deltamath, if you'll have problems like this. This is the discovery. So you're going to play around and try to figure out what's going on. So the directions say transform the solid black function to match the dotted function. So I've got the black function here, which if you look at your parent function chart, you can tell is an absolute value. It also tells you right here that you've got y equals the absolute value of x. So how do I get to this red dotted line? Well, right away you could see that it is flipped upside down. And so this right here, this flip, if I do this, it changes. So that's showing you how to change. So my goal is to get this black line to be up here to the red line. So I did a negative. Now I'm going to look inside the parentheses. And I'm going to look from this vertex, 0, 0. Does it go left or right to get to this vertex 1, 6? Well, yes, it goes 1 unit to the right. So remember, opposite day, inside parentheses, the right would be -1. and then when you click out of the box, it transforms your pictures. So there, I've almost got this. Now I need to figure out how many units does it go up to get that vertex right there. Well, you can see that it's 6. So if I type 6 and I click outside the box, the transformation, the black line is now on the dotted line. So you're trying to get it to match. Once you get it to match, you submit your answer. So you're messing with those numbers to get them to answer correctly. There's videos on here. This explains when you get, if you get the answer right or wrong. So take your time. You only have 5 problems to discover. Then the next part of this, I'm giving you 10 because this is like multiple choice. So if you're looking in the second part of your assignment on parent functions, it's asking which function represents the dotted graph. So here's my parent function. Okay, I can see that it's in a V shape, and if I'm not really sure, I don't care what shape it is. I'm trying to figure out how I go from a vertex of 0, -3, and I go over and down. It does not reflect or flip, so there's going to be no negative in front. So all I do is I'm going to count. It goes 1, 2, 3 places to the right. If it's inside parentheses, if it's moving left or right, opposite day, so to the right would be a -3. So I've got my point here, and it goes down 1, 2 places, so -2. So looking at your answer choices, you're looking to see which one matches up. So -3, -2. And then it will also show you and practice that. So you have 10 of those to do. So take your time. Hopefully you watch this video, or you can come to my Zoom sessions as well, and you know that you will do fine. All right, I will talk to you later. Hopefully see you